Hey, welcome back, Mastery Algebra 1. This is Mr. White. We're going to continue on with Lesson 7.3, but in a second, Mr. Fuller and I now are, instead of Math Men, we are Math Men and a Lady. We now have a guest speaker. We'll be taking over a couple times. This is Miss Swan.
Hey guys, I'm going to take you through Lesson 7.3 today, and we're going to look at another exponent rule to add to your books. So today we will continue our work with exponents, and in this activity we're going to develop another rule allowing us to work even more types of exponential expressions. So if we look at number 1, assuming the information available on the internet doubles every year. So if we think of doubles, we can think of as multiplying by 2. How much information will be available 4 years from now? So if it's doubling every year, our base is going to be 2, and if we're looking at every 4 years from now, our exponent will be 4. So 4 years from now, we're going to have 2 to the 4th the amount of information that was available 4 years ago or today. So if we look at part B, 4 years from then, we're going to have 2 to the 4th times 2 to the 4th. So we can also think of this if we think back to what we did in the previous lessons. 2 to the 4th times 2 to the 4th. Another way of writing this would be 2 to the 4th plus 4. So what's 2 to the 4th plus 4? We'll have 2 to the 8th. Another way of looking at it, if we have 2 to the 4th times 2 to the 4th, we have 2 to the 4th times itself. So we can write 2 to the 4th is being squared. And what did that equal? We said that equals 2 to the 8th. So if we move on to letter C, 4 years from then, so we're going to add in another 2 to the 4th. So for this one, we're going to have 2 to the 4th times 2 to the 4th times 2 to the 4th again. So if we use the same rule we applied above, that would be 2 to the 4th cubed, because we're multiplying it by itself 3 times. So another way to write that would be 2 to the 4th plus 4, which would equal 2 to the 12th. So we can say 2 to the 4th cubed would be 2 to the 12th. So if we put that all together, 4 years from now, 4 years from then, and 4 years from then, that would be a total of 12 years from now, or 2 to the 12th, as we said in part C. So if we look at number 2, suppose the amount of information now is x times as much every year. How much information will be available 3 years from now? So now we're saying it's multiplied by x every year. So our base is going to be x, and 3 years from now, so our exponent will be 3. So if we look at part B, 3 years from then, we'll have x cubed times x cubed, or x cubed squared. So if we think of that as x cubed times x cubed, would be x to the 3rd plus 3. So that would be x to the 6th. So x cubed squared would be x to the 6th. For part C, if we think of 3 years from then, we're going to multiply by another x cubed. So we'll have 3 x cubes, or x cubed raised to the 3rd power. So we can think of this as x to the power of 3 plus 3 plus 3, or x to the 9th. Take it a step further, 3 years from then, we'll have 4 x cubes multiplied together, or x to the 3rd raised to the 4th, since we have 4 of them multiplying together. We can think of that as x to the 3 plus 3 plus 3 plus 3, or x to the 12th. So hopefully you noticed the pattern by now. If we look at part D, we had x to the 3rd raised to the 4th power equals x to the 12th. So if you notice, 3 times 4 would get us that 12. So if we look back on part C, you can look that on this step, x to the 3rd raised to the 3rd power, 3 times 3 will get us that exponent of 9. So this will become a little shortcut we can use. So if we look at part E, if we add in another x to the 3rd, so x to the 3rd multiplied by itself 5 times. So if we use that shortcut, x to the 3rd to the 5th power, we would do x to the 3rd times 5, or x to the 15th. So putting it all together, 3 years from now, 3 years from then, 3 years from then, 3 years from then, and then 3 years from then means 15 years from now. or x to the 15th power. So what is a shortcut we can use for problems like this? So if we look at part E, where we had x to the third times x to the third 5 times. If we go back to the rule we learned previously, we could say this was x to the power of 3 plus 3 plus 3 plus 3 plus 3, which would be x to the 15th, correct? So if we look at this step right here, another way we could write this would be x to the third times 5, right? 3 plus 3 plus 3 plus 3 plus 3 is the same as 3 times 5. And that would get us our x to the 15th. So this is a little shortcut we can use when simplifying exponential expressions. So to generalize this, the power of a power rule. So when raising a power to another power, we're just going to multiply the exponents. So if we have b to the m raised again to the nth power, to simplify that, we're just going to do b to the power of m times n. So we're just going to multiply our exponents together. So let's look at a couple examples of that. So for part A, if we look at 3 to the 12th squared, we can also think of this as 3 to the 12th times 3 to the 12th. So 3 to the 12th times itself. So using the rule we learned previously, that would simplify as 3 to the 12 plus 12, or 3 to the 24. If we use the power of a power rule, we can kind of use a shortcut for that one. So we could say 3 to the power of 12 times 2, which would also give us 3 to the 24. So if we look at part D, if we use our power of a power rule, well, 6 to the 0 times negative 4. So if we multiply our exponents together, well, 0 times any number is just going to be 0. So 0 times negative 4 will just give us an exponent of 0. And we said any number raised to the power of 0 is going to be what? Just 1. So 6 to the 0 power, all raised to the negative 4th power, will just give us 1. So let's try G as well. So if we use the power of a power rule, we're just going to multiply our exponents. So negative 7 times 9. Well, negative 7 times 9 will get us negative 63. So if we have y to the negative 63, we have a negative exponent, so we need to flip and use the reciprocal of that. So we're going to have 1 over y to the 63rd power. So go ahead and hit pause and try the last 6 on your own, and check back in a minute for the answers.
The other thing, you feel yourself rushing sometimes, the other thing to do is just turn it.
So if we check back and check our answers for B, we just multiply the exponents. So 3 times 7 will get us an exponent of 21. So we'll have 2 to the 21st power. If we look at ones like these, the directions say write an expression with one positive exponent. If we had a problem where we ended up with an answer such as 1 over 2 to the third, well, 2 to the thirds, that one we should be able to do in our heads as 1 over 8. When we get to powers like 2 to the 21st, though, that's not so easy to do in our heads. So let's say anything above an exponent of 6, we'll just leave it as, such as the example 1 over 2 to the 6. Instead of simplifying that one, we can just leave it with the exponent. So E, you should have gotten p to the positive 18th. Remember, negative 6 times negative 3 will give us a positive 18. H, m to the 0, we want to make sure to simplify to 1. C, should have gotten x to the 16th. F, we should have, when we simplified all the way, 1 over 5 to the 12th. And I, we should have gotten c to the 24th power. All right, so let's look at another property we can use. So raising a product to a power. So to raise a product to a power, we need to raise each factor to the power and multiply. So if we think of the word product, product means we're multiplying two things together. So if we look at the algebra way of writing this, if we had a times b, all raised to the nth power, we will simplify this by saying a to the n times b to the n. So we're going to raise both a and b to the nth power. We want to make sure a is not 0 and b is not 0, and n is a rational number. So your exponent's got to be a rational number. So if we look at examples, so if we had 3x all raised to the 4th power, we need to take 3 to the 4th power as well as x to the 4th power. So when we simplify, that 3 to the 4th power will become 81. And similarly for the next example, 4b raised to the 3/2 power. So if we do an example of this one, so we're going to simplify a product raised to a power. So it says, which expression represents the area of a square? So area of a square would be the side length squared, and it gives us a side length 5x cubed. So if we plug in that 5x cubed into our area formula, we would get 5x cubed all squared. So now we have a product being raised to a power. So if we use that formula from above, we need to take each factor and square it. So this would become 5 squared and x cubed squared. So we're just taking the 5 and raising it to the squared power and the x cubed raised to the squared power. So 5 squared would be 25. And if we use our power to a power rule, x cubed raised to the 2nd power would be x to the 3 times 2, or x to the 6th. So that would be letter D. Let's look at number 3. What is the simplest form of each expression? So more products raised to powers. So if we look at letter A, we have 7m to the 9th all raised to the 3rd power. So we need to make sure to take both factors and raise them to the 3rd power. So we're going to take 7 to the 3rd power and m to the 9th to the 3rd power. Well, 7 to the 3rd power will give us 343. And if we use our power to a power rule, we would get m to the power of 9 times 3. If we simplify further, 9 times 3 will give us an exponent of 27. So at the very end we get 343 m to the 27th power. All right, go ahead and hit pause and try B and C on your own and check back in a minute and see the answer. All right, welcome back. All right, problem 4, simplifying an expression with products. So now we want to simplify this expression, n to the 1/2 raised to the 10th power times 4m n to the negative 2/3 all raised to the 3rd power. So let's take this piece by piece. Let's look at n to the 1/2 raised to the 10th power. So if we use our power to a power rule, that would simplify to n to the 1/2 times 10. And if we look at the next piece, 4m n to the negative 2/3 all to the 3rd power. So we need to distribute that 3rd power to every term in that expression. So that means we'll have 4 to the 3rd power, m to the 3rd power, and then n to the negative 2/3 to the 3rd power. So take this a step further. This n to the 1/2 times 10, we can simplify. 1/2 times 10 will get us 5. So now we just have n to the 5th. Here we're going to have 4 cubed. So 4 times 4 times 4 will get us 64. M cubed, nothing we can simplify on that one. And then we have n to the negative 2/3 times 3. So if we have n to the negative 2/3 raised to the 3rd power, we can use our power to a power rule. So negative 2/3 times 3, or 3 over 1, should end up with n to the negative 2. Our 3's will cancel out on that one. So n to the negative 2. All right. So now we need to look to see if we can go any farther with this. Let's think back to our combining like terms properties. So I see 2 n terms that we can combine. So nothing I can combine with my 64, so I'm just going to leave that. And I don't see any other m's, so just bring out my m to the third. And now I have n to the fifth times n to the negative 2 power. So if we think back to our exponent rules that we learned in the previous section, so n to the fifth times n to the negative 2, we can think of that as n to the 5 minus 2, or n to the third. So all simplified, we should end up with 64 m cubed n cubed. All right, go ahead and hit pause and try 4a through c on your own, and check back once you're done. All right, welcome back. So, raising a number in scientific notation to a power. So connecting what we learned back in last section about scientific notation. If we have an aircraft, the expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the third kilograms, traveling at a speed of about 3.1 times 10 to the third milliseconds? So if you notice, as I read through those, I like to highlight all the important information that I think I'll be able to use when plugging all this in. So I know my expression that I need to plug into for the kinetic energy is 1/2 mv squared, where the mass was m and the speed of v. So if we plug in those information that it gave to us, well, it said the mass of the unmanned jet is 1.3 times 10 to the third. So if I plug that in for m, we should get that, and we know that speed, or v, well, it was traveling at about 3.1 times 10 to the third milliseconds. And v in our formula was squared, so don't forget to tack that on the end. All right, so now we need to simplify this expression. I'm going to look at this squared term first. So if I wanted to simplify that, I'm going to leave these first two factors alone. So 3.1 times 10 to the third squared. We can rewrite that as 3.1 times 10 to the third times 3.1 times 10 to the third. So if we look at it that way, we're just going to multiply the 3.1s together and multiply our 10 to the thirds together. So 3.1 times 3.1 will get us 9.61. 10 to the third times 10 to the third, well, we have the same base, so we can just add our exponents together. So 3 plus 3 will get us 6, so we'll have 10 to the 6th power. So plugging that back into our formula, we have 9.61 times 10 to the 6th power. All right, now we need to simplify a little more. We need to multiply both of these factors together. So if we use the same method we used in the last step, to combine these, we're going to take 1.3 times 9.61 and 10 to the third times 10 to the 6th. So if we multiply that out, we should get our 1/2 is still out there. 1.3 times 9.61 should get us 12.493. And then we need to multiply our 10 to the third times 10 to the 6th. We can add our exponents and simplify, so we get 1/2, 12.493 times 10 to the 9th, once we add those exponents. So last step, we need to simplify this 1/2. So if we multiply the 1/2 by our 12.493, so half of 12.493 should get us 6.2465. And then we still have that 10 to the 9th power at the end. So now we know that the kinetic energy in joules, so that should be our unit, of this unmanned jet will be 6.2465 times 10 to the ninth joules. That would be our final answer. All right, go ahead and hit pause and try number 5 on your own. Very similar to the last example, and check back once you're done. All right, welcome back. So if we look at number 5, it's asking what is the kinetic energy of an aircraft now with a mass of 2.5 times 10 to the 5th kilograms, traveling at a speed of 3 times 10 to the 2nd milliseconds. So if we plug all that information in at this step, once we simplify all the way down, we end up with 22.5 times 10 to the ninth. So once we get to our simplified answer of 22.5 times 10 to the ninth, for scientific notation, we need to remember that our first number needs to be between 1 and 10. 22.5 is a little greater than 10, so we need to figure out a way to get this between a number of between 1 and 10. So one way to do that, we're just going to move our decimal place to the left 1 decimal spot. So then we should end up with 2.25. Since we moved our decimal to the left 1, we need to increase this exponent on the 10 one number. So we should end up with 2.25 times 10 to the 10th joules. As a complete sentence, the kinetic energy of the aircraft would be 2.25 times 10 to the 10th joules. All right, that's all for notes. Don't forget to turn to page 436 in your textbook and complete numbers 10 through 40 even. Do your best, forget the rest. Bye for now.